7 Ways to Murder Your Diesel by Capt Frank Lanier. I originally wrote this article back in 2022, and it won a first prize award in the Boating Writers International writing competition. So I was asked to speak at the Seven Seas Cruising Association GAM in October of 2023, and I decided to convert this article into a slideshow presentation, and that's what you're seeing now. The deed is done and it's murder most foul. Your loyal diesel engine has met an untimely end, cut down in the prime of its expected service life. Who's responsible? Colonel Mustard in the library with a Yeti paw? Miss Scarlet in the foyer with a loofah? No, it was you who murdered your diesel due to lack of maintenance. Let's consult with the world's greatest detectives to uncover clues about the surprisingly simple ways you ushered your diesel engine to an early demise. Clue number 1. It's elementary, my dear Watson. The owner failed to change the oil. It doesn't require a visit to 221B Baker Street to discover that regular oil changes are the single most important thing you can do to maintain the life of your engine. Most engine manufacturers recommend oil changes every 100 hours or annually at a minimum. Some engine manufacturers may allow longer intervals, but more frequent oil changes, rather than stretching out the periods between them, are a better strategy to extend the life of your engine. This is particularly true for diesel engines, which tend to be harder on oil lubrication properties than gasoline engines. This is one reason many experts suggest the oil for a diesel engine be changed every 50 hours of use, rather than the 100 hours commonly quoted. While it should go without Sherlock saying it, always install a new oil filter when changing the engine oil. Clue number 2. All we know are the facts, ma'am. It's obvious that the owner failed to test the engine warning alarms. Most all engines have temperature and oil pressure alarm systems consisting of audible and visual alarms, and these can fail over time. In many catastrophic engine failures due to overheating or loss of oil pressure, the alarm system is inoperative, a problem often unknown by the operator. While not a direct cause of engine failure, failure of the audible alarm or lack of one is a major contributor. Most engine manufacturers use the same buzzer for multiple monitoring systems: oil pressure, engine temperature, and sometimes alternator output. The problem is that the buzzer can sound if one or even two of these 3 monitoring circuits has failed. When you turn your engine ignition on, the buzzer you hear is confirming operation of the low oil pressure alarm. Placing the engine ignition in the on position without actually starting the engine simulates a low or no oil pressure situation. The ignition is on, but there is no oil pressure as the engine is not running. If you don't hear this alarm when starting your engine, chances are there will be no alarm should loss of oil pressure occur. While this simple test verifies that the low oil pressure monitoring circuit is working, it doesn't confirm that other engine alarms, engine overheat, or alternator output are functional. As mentioned previously, one or both of these could be faulty, even if the buzzer sounds at the engine startup. On many of the vessels I survey, the audible alarm system has long since stopped working properly, typically due to a broken sensor wire or corroded connections. By the time the operator notices the problem, either by glancing at the temperature gauge or via the smell of an overheating engine, the damage is already done. Engine warning alarms should ideally be verified annually, every 2 years maximum. Clue number 3. Oh, sir, just one more thing. You didn't change your fuel filters. Colombo knows fuel filters are always clogged at the worst possible moments, such as running a narrow inlet or when navigating a busy harbor. Causing your engine to shut down during a crucial evolution is bad enough, but it gets even worse. Clogged fuel filters can also damage injectors and injection pumps. Fuel filters should be changed regularly and replacement dates logged along with your engine hours as part of your vessel's preventative maintenance program. Clues your filters are clogged or need changing: 1 would be engine surging, 2 would be reduced power, 3 excessive black smoke, and 4 complete shutdown. Many engine problems that appear to be mechanical in nature can often be traced to a clogged fuel filter. A good way to monitor fuel filter condition is to install a vacuum gauge. Little or no vacuum means the filter is clean, while high readings on the vacuum gauge indicates that the engine is sucking harder to get fuel through the filter, a sign that it's clogged and needs replacing. Vacuum gauges can be inserted into the line between the primary fuel filters and lift pump, or in many cases, screwed into the top of the filter housing cap, replacing the T-handle. Just be sure to keep the handle mounted near the filter for emergency use should the vacuum gauge fail. Clue number 4. Observe number 1, son. Air filter has not been replaced. You don't have to be as smart as Charlie Chan to see a pattern here regarding the benefits of routine maintenance. Even simple ones, such as maintaining your air filter, can make a big difference when it comes to increasing your engine's service life. Black exhaust smoke, loss of power, increased fuel consumption, and overheating are all possible clues that your air filter is in need of cleaning or replacing. A clogged air filter can also cause your engine's turbo, if so equipped, to spin faster in attempts to provide the engine with adequate airflow. Severe damage to valves, pistons, and the turbo itself can occur if contaminants from a clogged air filter are ingested by your engine. Clue number 5. Read the smoke signals, 6, 2, and even, over and out. It doesn't take a two-way wrist radio or even a bulldog jaw for Detective Tracy to communicate the cause of your engine's demise. Exhaust smoke is your diesel's way of telling you what's going on, and correctly reading the signs can head off potentially expensive repairs. A well-maintained engine may smoke when initially cranked or while idling, but typically not while under load. White smoke during startup of a cold engine is normal, but it should clear up once the engine warms up. If it continues, it's normally an indication of unburnt fuel, but it can also be a number of other issues, from water or air in the fuel to a faulty injector, injection pump, blown head gasket, or even a cracked cylinder head or liner. White smoke can also be a sign of engine overheating. However, the smoke in this case would actually be steam produced as raw cooling water passes through the exhaust system. Overheating due to a clogged exhaust elbow would be a good example. Black smoke upon startup is also common. However, its presence after the engine is under load indicates incomplete combustion. Possible causes range from air intake or exhaust restrictions, compression problems, and faulty or worn injectors to engine overloading due to an oversized or overpitched propeller. Blue smoke means the engine is burning oil, which is also not uncommon at startup. Continued smoking, however, may indicate trouble with valve guides and stems, worn piston rings, or failing turbo supercharger oil seals. Clue number 6. You poisoned your engine, monsieur. While not as exciting as murder on the Orient Express, follow Hercule Poirot's advice to use your little gray cells, and you'll soon surmise that many marine diesel problems originate in the fuel tank. The key to keeping a diesel engine happy is clean fuel. The reason for all of this clean fuel hubbub has to do with your engine's fuel injectors. These precision-tuned components deliver a precise, ultrafine mist into the combustion chamber. They don't like contaminants not one bit, and even microscopic specks of dirt or water can wreak havoc on the combustion process, as well as your injectors and junior's college fund. Not surprisingly, water intrusion is a major source of diesel fuel woes for boats. That deck fuel fill cap with the missing O-ring is a perfect path for water entry into the fuel tank during every washdown, rainstorm, or wave on the deck. Diesels use pressure to generate combustion, and when water enters the engine, it turns to steam, which can literally blow your injectors to pieces. Water also mixes with the sulfur in your fuel to create sulfuric acid, sort of like the blood in those alien movie critters, which can cause internal engine parts to corrode. Limited or seasonal use is also an issue when it comes to boat fuel. Despite the plethora of magic potions and elixirs sold to kill bugs or stabilize your fuel, diesel stored on board for long periods can still degrade or become contaminated due to microbial or bacterial growth. As water enters into your fuel tank, it eventually separates and settles to the bottom, a common problem with long-term stored fuel. That's when things get buggy. Microbes thrive in this water, and their only goal in life is to eat and multiply. Sure, you can add biocides after the fact and kill the little troublemakers, but as any good hitman knows, killing's the easy part. The problem is disposing of the bodies. In the case of dead microbes, they'll lay in wait at the bottom of your tank until that first rough passage. then rise up zombie-like to clog filters and in general wreak vengeance on your fuel system and worse still, your engine. While you should always use a filter funnel when taking on fuel, the best strategy is to take on fresh, clean, water-free fuel to begin with. Choose marinas that have a high rate of fuel sales and thus fuel turnover. One of the best marinas I've ever seen in this regard was located beside a major highway and also served as a truck stop. If you have any doubts about the cleanliness of the fuel down at the Rake and Scrape Fritter Shack and Marina, pump a small sample into a clean glass jar before fueling and let it sit for a few minutes, after which any water and dirt present will settle to the bottom. If you see either, buy your fuel somewhere else. Clue number 7. The avoidance of idiocy should be the primary and constant concern of every intelligent person, lectures Nero Wolfe. That being an undeniable fact, why would the boat owner fail to replace engine manifolds and exhaust risers at the recommended intervals? Exhaust manifolds and risers are metal castings that carry hot exhaust gases away from the engine. Manifolds are located along the side of each cylinder bank. The riser or exhaust elbow, which often resembles an inverted U, is mounted atop the manifold and is where the exhaust hose is attached. They are double-walled, essentially a pipe within a pipe, with exhaust gases contained within the inner pipe being surrounded by cooling water contained in the external pipe, aka the water jacket. At the discharge end of the riser, water from the water jacket is combined with the hot exhaust gases, after which the mixture is then discharged into the exhaust hose and overboard. Here we have an example of a particularly bad-looking exhaust elbow or riser. If it looks this bad on the outside, you can just imagine how 10 times much worse it looks on the inside. It's not uncommon for exhaust manifolds or risers to fail after 5 to 7 years due to corrosion. Now, I've put a little note in here, raw water cooled engines. If you have a raw water cooled engine, raw water just means the engine is cooled by whatever you're floating in. And that could be either salt water or fresh water. If you have it's also called an open system or an open exhaust system. If you have a closed system or freshwater cooled engine, that means you have essentially two systems. You have a open system that brings in raw water, which is again just what you're floating in, and it goes to a heat exchanger, and there it cools, or the heat is exchanged from the closed system, which utilizes antifreeze. So that's the difference. You have an open system and you have a closed system. Both of those together, if you don't have a antifreeze, a closed system, then you have a raw water cooled engine. Now, what we're talking about here when we say, exhaust manifolds need to be replaced every 5 to 7 years, this is for engines that are raw water cooled, which are subjected to a lot more corrosion than a closed or freshwater system, particularly if the engine is operated in salt water. So, getting back on track here, if you have an exhaust manifold or an elbow or riser that fails, water can then seep into the cylinders while the engine is not running and cause a myriad of problems, from seized pistons due to corrosion to a condition called hydrolock. Hydrolock occurs because water is not compressible, meaning that the engine can suffer catastrophic damage if started with water in the cylinders. One clue that trouble is brewing within your exhaust riser is an increase in temperature, a typical sign of reduced raw water flow. A simple way to detect this is to periodically feel or measure the temperature of the exhaust elbow during engine operation to verify that it's maintaining a normal, even temperature. You can also compare the temperature of the water exiting the exhaust elbow with the ambient raw water temperature. This temperature difference will vary between engine models, but is typically around 40 to 60 degrees Fahrenheit. For example, if the incoming raw water temperature is 75 degrees Fahrenheit, the water exiting the exhaust elbow should be in the range of 115 to 135 degrees Fahrenheit, making the elbow warm to the touch but not excessively hot. In any case, the exhaust water temperature should never exceed 200 degrees Fahrenheit. Rather than consider manifolds and risers permanent parts of your engine, they should more correctly be viewed as engine consumables, no different than belts or oil filters. Due to the serious potential for damage, many engine manufacturers recommend that manifolds and risers be replaced every 5 years. The cost of stretching this period out or ignoring it altogether can be expensive. And again, when we're saying for the manifolds every 5 years, that's typically if the boat is raw water cooled or operating in salt water. You would want to consult what your engine manufacturer recommends for inspection and replacement of your manifolds and risers. Buying a boat and not sure if or when the manifold or risers were replaced. The seller says it was a couple of years ago, but he can't find the paperwork for some reason. Take another bit of advice from Nero Wolfe and be a card-carrying pessimist in such cases. That is, of course, the advantage of being a pessimist. A pessimist gets nothing but pleasant surprises, an optimist nothing but unpleasant.